Hello everyone, let's take a look at LeetCode 407, Trapping Room Water 2. It's a very good problem and it's a hard question. And the key idea of this problem is using PredicQ and BFS. Okay, there's a very similar question in LeetCode 42, Trapping Room Water 1. So if you haven't practiced this problem, you should practice this problem first. For LeetCode 42, it's more like a one-dimensional problem. For this one, it's like a two-dimensional question. Okay, so the problem is like this. We have a two-dimensional array. Each cell is an integer value represent like the height of this bar. So we want to calculate for this two-dimensional matrix how much water it can keep. Okay, it's a little bit like the Kenkin law. So the height of the minimum bar is the most important, like to how much water we can keep. So, like the Kenkin law, we just for loop the edges, like the green color, the green cells here. We just iterate all the green cells and get the minimum height. So in this case, the minimum height is 1. Also, we need to push these green cells to my queue. It's a priority queue. So it's a pair of integer and integer. The first element is the height of that cell. The second element is the position. Of course, we can also use pair integer to represent the partition. But here I just use the integer. We need to do some transformations, conversions. Also, I mark the green cell as visited here. Okay, now we have minimum, which is 1. Okay, what should we do next? Imagine that the green cell is a wall and we want to proceed to the center. So each time we also need to update our minimum. The minimum will become bigger and bigger when we proceed into the center. Okay, every time we pop the minimum element in my queue. So at first, the height is 1, assuming I'm popping this cell. So for this one, I will try to, like when we pop it, I will try to iterate the 4 directions. For example, for this 3, we haven't visited it. So it will add this 3 to our priority queue. And next, we pop this one, and all the neighbors are visited, so nothing happens. Next, we pop this one, all the neighbors are visited, so nothing happens. Okay, next, we visit this 2, we pop this 2. Something happened here. As we mentioned, we need to like proceed to center. And for this 2, like when we pop it, we need to update the minimum. Now the minimum becomes 2. Okay, next, we are at this 2 and all the neighbors are visited. Pop this 2, all the neighbors are visited. Okay, next, assuming we pop this 3. Similarly, we need to update the minimum. Now the minimum is 3. Okay, then we find 3 has 1 neighbor, which is 1, hasn't been visited. So currently the minimum is 3. The height of this cell is 1. So we can keep 2 units of water. So we update answer to 2. Also, we add this element to priority queue. Next time I pop this 1, and the neighbor 2 has not been visited. Minimum is 3, height is 2. So we can keep 1 unit of water. And we add this 2 to priority queue. Next, we pop this 2. Nothing happens since all neighbors have been visited. Okay, next we like pop 3, nothing happens. Like next we pop this 3. It has 1 neighbor, okay, which is 2. So we update answer to 4. Since minimum is 3, height of this cell is 2. So we can keep 1 unit of water here. So answer becomes 4. And we add this 2 to priority queue. Okay, next, nothing happens since all the elements have been visited. So we just pop, keep popping until my queue is empty. So the code looks like this. Every time we get the top element of this queue, and we just convert the position, the coordinates, and we want to update the minimum. Next, we will try to visit the 4 neighbors, And as long as there's the position is valid and it has not been visited, we will try to mark it's visited. Then we will try to like to say if such cell can keep some water and update our answer. At last, we just push this new cell to our priority queue. Okay, that's it. See you next time.